But so right now, I'm going to introduce our next guest. It is Evan Shapiro from the Mina Foundation. He is a graduate of CMU, where he got his BS in computer science, and stayed to get his master's working in the CMU Personal Robotics Labs, which is super awesome. He worked as a software engineer for Mozilla, and then went on to co-found and serve as CEO for O1 Labs, and is now currently the CEO of the Mina Foundation. I am super excited for this presentation, and it is my honor to invite Evan Shapiro up to the stage.
Hello, cool. Thank you for the intro. Hey.
Awesome. The floor is yours.
Cool, thank you. So first we're gonna try sharing a tab and see if it works. And it does. Cool, okay. So when I was thinking about what to do for this, what to talk about today, one thing top of mind was some of the work that ChainSafe is doing on making it possible to have a Mina node that compiles to WASM, which then can kind of work everywhere in a fully trusted way. And that got me thinking about what it would look like to actually kind of follow through on the full vision of this private verified Web3 world with Mina as like a backbone. So this talk is me thinking through what has to be done to actually make that possible. So I hope that is interesting to y'all. So what do I mean when I say private and verified Web3? I mean making crypto internet native without any additional trust assumptions. This means that we want to be able to build things as developers on the internet, and you use the internet as if it was a crypto application with all the trust guarantees that provides, all the privacy guarantees that provides, which seems like that's a very powerful set of primitives. We could do a lot with it once we have the set of underlying APIs. So I'm imagining a world here where users can use the internet without disclosing any personal information. They submit proofs of their information and some other ways of getting sensitive information on these applications without actually exposing the sensitive information itself. And they have tools to trust the information that they're presented on the internet is actually real in some sense. We kind of get this for free in a lot of ways on crypto. We know that the balances and accounts, for example, are backed by valid sets of transactions. It seems like there's probably some very powerful primitives you could build with this on the internet around seeing who in your social network, for example, has trusted certain web pages, or otherwise knowing the computations delivered to you by some centralized server actually are following some set of rules given in crypto. So, and for developers, this is also some pretty cool set of things we can do. We want easy APIs to be able to access this stuff. We could imagine with this that developer would be able to build an application without having to take hold of any confidential information. So if you imagine something like GDPR, they don't even have to take ownership of that sensitive information, so they can avoid having to deal with all those regulations while still getting to like the API solutions they're looking for in terms of the actual functionality. And also, I think with this, we could imagine things being fully censorship resistant, fully on crypto in a way where you deploy it, you kind of know the guarantees around how it will stay up. And I think that could be cool as well when you're thinking about deploying an application. So to give an example of what this could look like, I want to give a couple examples. So the first is anonymous voting for a neighborhood. So in this example, you're going to go to a website, it's going to send you a proof of the state of some vote that's going to happen. So it's going to say, this is a vote that's happening. Here's who's eligible to vote in it. Here's the status of it so far. And then you want to send an anonymous vote, proof of your vote and your physical address. So I want to say, hey, like, here's a proof I actually live in that neighborhood, but I don't actually want to, disclose this to this website where I actually live. And I don't want to disclose my particular vote as well. The application proves the result of combining everyone's votes. And then the site sends a proof of the new state, so you actually know what the result of the vote is. So it sounds a little magical. We'll get into how we can actually do this later, but just an example. Another example, kind of closer to home with the DeFi stuff happening right now. You visit a site, it sends you a proof. This is just more for fun, not necessary for its application. Some of your friends are using this service without revealing exactly who is using it, so you can trust it. You send the site a proof of your identity. And in this example, I'm saying your identity is registered with some mutually trusted third party, just because that kind of makes it easier to think through. There's probably ways around that. You then send the site a proof of your credit history, both on and potentially both off-chain and potentially on-chain, depending the state of crypto future, where there's some history actually built in on-chain in that future. So you can get the best terms that are revealing any of your information. So in this example in particular, you reveal proofs of things on and off-chain, but not the actual information itself. But that's used so that they can actually decide what kind of terms to give you. You receive the loan. And the loan provider has some terms set up. So if it can prove that you were non-compliant with the terms of the loan with the zero knowledge proof, you actually can prove that you were non-compliant and versus the rules you actually signed up for, then it can go to that third party and get your identity out. Probably not I think eventually it'd be nice to end up in a state where that stuff didn't even exist, but maybe as like an intermediate solution, at least in this world, you have full privacy end to end as long as you're compliant with something that is on chain. So that's pretty cool. So what would we actually need to make this possible? So like I mentioned, ChainSafe is doing work on making Mina full nodes verifiable in WASM, which is definitely a big part of making this happen. So that's in progress. That's cool. Having Mina applications and data fully verified in the browser. So this is kind of done through Mina's succinct zero knowledge proof. But to have actual applications work for this as well, we need some kind of actual application layer. And this is what OF1 Labs is working on with Snaps, which is in progress. And there's actually a workshop on for the ZK Summit in a few days. So that'll be cool to see a preview of that. I want to say the docs are also out for that either today or tomorrow, like it just happened. So anyway, that you can check that out if you're interested. In this world also, users don't submit their data. They submit proofs of data back to the application. So they don't send their credit score, they send proofs of things. And then also we're probably gonna need a lot of libraries for this. Some of these are in progress, things like handling data storage, submitting data, making it easy to write these Snap applications. So I put a little, kind of work in progress thing here because some of those are in progress, some of those probably still need to be built. But I'm going to talk about these three right now in terms of ones that how this could actually fit together once we have it kind of all working. So the Mina architecture today is as follows. So you have some validators and they are one of them is elected to make a block. This is randomly by using their stake. They choose some transactions, they make a block out of it. They submit that block with a little checkbox, which represents a proof to the gossip net. That is then added to the chain of blocks. And yeah, so that's basically how it works. We can imagine that we have to add on some stuff if we actually want this to work on the internet. So for one, if we imagine everyone's devices connecting to a single gossip net and sending around these full blocks, that might be a little heavy if there's a lot of these nodes connecting. I think we'll have to actually see what the performance is. Maybe this extra step isn't necessary, but at least here I have a parallel gossip net that only is sending around proofs of the Merkle root of the ledger and proofs of the consensus state. So that's a much more lightweight thing to be sending around on a gossip net. So maybe you could have a lot more nodes actually involved on this. So then after that, you have your device, which connects to the gossip net. They know from the guarantees of the gossip net, they're not being eclipse attacked, and they can actually get the strongest proof of Mina on the chains, which gives them a proof of the Merkle root of Mina. This then leads to them saying, okay, now I want to get the state of some particular account, say the account that has the voting information on it in our voting example. So now they have to do some API to request paths down from that Merkle root down to a particular account. And what's cool about this is these data providers can't lie about the actual state of the application because you know the Merkle root already. You can look at the path and you know if it's right or not, but they can withhold information. So I'll get to this potential protocol for this on the next page, where if you have n of these providers, as long as one of n is valid, you're good to go. Lastly, the client creates a Snap transaction in their browser by producing a snark proof just locally in the browser, and then submits that back to the network. Then they wait a little bit, and then the proof gets re-gossiped out with the new Merkle root. They check the state of the application, and then they know that the new state of the application is. And what's cool is that they are able to do this in a way that's fully trustless from their own device, which kind of starts getting us to a state where we can do the things mentioned or the examples in the previous page. Here's a brief idea for a protocol that allows us to do the data providing in a way that is fairly trustless. Say there are n data providers that a client can talk to. We assume that at least one of these is responsive. We need one of n to be online for this to work. The web client locks X plus Y dollars with some conditions. If the client submits a proof from the data provider gets X dollars, the client gets back Y dollars. If the client does not submit such a proof at some time period, any data provider can, or anyone really can submit a transaction that gets them the Y dollars and burns the X dollars. So then a data provider sends the client the account data and a proof of the data at the end of a Merkle path randomly determined by the requesting account. So this is something that no one has control over, this Merkle path. And presumably the client doesn't have it. If they had it, then they would probably also have the original data they're looking for. So it's something they need to get back from the data provider if they're going to be able to have that information. So the data provider knows that if it submits this data and the proof to the client, either the client will pay that back to the, we'll post that onto the blockchain and the data provider will get paid X dollars. Otherwise, the client will have, if it doesn't submit that, will have burned X plus Y dollars. Client probably doesn't want to do that. And again, the client probably can't make the proof himself since it doesn't have that random Merkle path. So probably some more needs to be written up on this, but basically there's probably some good ways that we can make it so that you can fairly trustlessly as a data provider know that you're going to get paid for providing data to a client. So I think with this, we'd actually be in a place where we can start building small applications that are serving small numbers of users. But this leads to another question, which is if we wanted to do this in production at scale, what else would we need from Mina? So we would need much higher throughput, we would need instant finality, and we would need very low block time. Maybe you don't need all of these for all applications, but I was kind of thinking through, okay, what if we wanted to do this really at like what web scale? If we wanted to have all these things working, what would we need? So the Mina architecture today has some of the properties to make a smaller application that's more on the scale of what we see with Ethereum set today, but if we wanted to make it bigger, we'd have to improve some of these things. So Mina right now has only one producer elected per block, so it has probabilistic finality. You need a bunch of these lined up in order to have guarantees that any individual block is correct. It's exponential, so you get it pretty fast, but still probabilistic. You have about 1 TPS, and you have about a 3-minute block time. 1 minute of that about is the time to make proofs, and 2 minutes of that is the time to propagate this stuff over the network. So let's see where we can start improving some of these. So for next steps with Mina. So for one, if we want to have instant finality, instead of having it be that you have to look at many blocks with many different participants to get some certainty, we can instead elect multiple winners per block. So in this world, what we do is instead of the VRF returning one winner, we have the VRF return multiple winners that then form a committee that then select a leader among themselves, and then that leader then produces a block. And then what happens is that block is finalized if you have enough committee members looking at that block. So that's pretty cool. I mean, this is like, a bigger change to the protocol. I'll get into I think, we need to basically embark on a project to start doing all these things, but this would give Mina this full functionality of instant finality with the additional properties I mentioned earlier. So, and then a path to improve throughput. So for one of these things, O of1 Labs is working on an improved networking layer, which will vastly increase the rate at which we can get things through the gossip net. So that should already be a big improvement. But another possible cool idea that we could do here, and something that there's already somewhat of a prototype being worked on at O of1, is this concept of L1 level rollup pools. So you can have, instead of posting 10 transactions to the network, you can post a rollup for a particular account of 10 transactions where you post only the hashes back to the actual chain. And what this can let you do is push much larger volumes of transactions onto the network, where from the actual protocol perspective and the gossipnet perspective, you're only pushing one transaction, but that transaction represents many transactions that are rolled up. So this is somewhat, you can think of as rollups that are kind of native to the L1 in a sense, and can make it really easy for different applications to have their own rollups that then enable Mina to have much higher throughput in general. Let's say that with this improved networking layer and some other optimizations, we can eventually get up to, say, 100 TPS is an improvement. And then you can have these roll-up layers that are each themselves doing very large throughputs. Then you can have the opportunity to have very, very high transactions being confirmed back to the Mina mainnet. So I think that's a potential route, taking advantage of roll-ups to do that. Lastly, we have the concept of improving latency. So right now, there's two things that are keeping this slow. One is that actual proofs of blocks are computed with each block, which adds a minute delay to producing a block. This is being reduced further. I think around on the order of 2x, so still maybe around 30 seconds. But even so, 30 seconds is still kind of a lot when you're thinking about block latency. The other half of this is the actual networking layer itself. Again, the new update to this should make it a lot faster. If this gets to this point where it's on the order of other networks around 10 seconds, we can imagine being in a place where it's around, let's say, 10 seconds to do the propagation and 30 seconds to produce the actual block production. Still 40 seconds, so we want to make that better. One possible way to do this is to defer the proving of each block until later. So each block includes a proof of a previous block, but not the proof for the current block. So you don't have to wait to make that proof. So you can see an example here. If we're making block 4, we can include the proof to block 2. So when block 2 is created, let's call that time 0. Block 4 won't get created until block 3 is actually seen at time 1, but that gives us between time 0 and time 1 to make the proof to block 2. So in doing that, we have this whole chunk of time where snark workers can go and make this proof. So by the time it's actually time to make block 4, the proof that we need to include for that block for block 2 is all ready and everything, and we can just include it and then we're good to go. So with that, when block 4 is time to produce, it can just be turned out really, really quickly. It can go over the gossip net, and very quickly we can improve block latency, basically. So to kind of put this all together, we would want to be in a place with this where we have multiple people making each block, so we get instant finality. We have an upgraded networking layer so that we can have higher throughput and we can have better latency. Proving is also deferred for higher latency. There's higher throughput because we have these roll-up pools that allow us to have many transactions in one, and the networking layer is a little better. So between all this, we can start getting into a place where we can start achieving this end goal of websites that are fully verified end-to-end using Mina zero-knowledge proof and allow users to submit private data back to the chain. So, okay, so in summary, what does this all get us? So if we want to go back to this voting in the browser example, the user's client downloads the proof from Mina, and it does this by connecting to a gossip net, so there's no additional trust guarantees for consistency on top of the core protocol. And users get this entire proof of the application's particular history through Mina zero-knowledge proof. User downloads paths to the voting application's accounts. So let's go to the next one. So in doing this, they get pretty strong guarantees on data availability. If there's any of these data providers, as long as one of them are compliant with the protocol, you're good to go. User can submit their vote to the network with private information, so they can just submit proofs of their vote and proofs to the network, so they don't have to actually expose particulars about their identity or particulars about their vote to the network. And lastly, the network can process the transaction very quickly. This can be submitted to one of these roll-up application layers, which can put everything together and get it on chain at very high throughputs. We can have instant finality through many signers signing each block, and we can have low latency due to deferring the proving time and a faster networking layer for getting these proofs out to the network. So between all that, we can have applications that have all these properties together, which I think would be pretty cool. So in summary, clients can connect from the browser, from their phone. They get full access to cryptocurrency with all the guarantees you would want as if they were running like a full node, and they get privacy when they interact with the chain. Developers can take advantage of sensitive information without taking on storage and like privacy risks or having to think about the complexities of having to go through all the extra steps of making sure they're handling data in a good way that's good, because they don't actually even take hold of that data ever. It's all just running on chain in a way that's fully private. And also developers can get access to crypto infrastructure with very few trade-offs. It's all running in the browser. It's all running just from them being able to connect to Mina through all this extra stuff that would run under the hood in this future world. So yeah, I mean, this is something that I'm very interested in seeing if we can help make happen. I think, this is probably a multi-year vision, but something that if we can get Mina to do it, I think would just be really awesome to have, and as well, like a good direction for Mina to go in. So if you're interested in Mina generally, here's just the general links you can check out the protocol on. The Twitter is probably the place where we post most things on. We're also looking for a developer advocate right now. So if you're looking to help build out some of these early Snap applications and help get the developer community going with what it would look like to be able to really easily build in JavaScript and TypeScript with zero knowledge proofs, you can check that out. There's a few other open positions you can check out too. That's all I have for this talk. Thanks for listening, and happy to answer any questions.
That's super awesome. Thanks so much, Evan. Mina is super exciting, even from what I know, even currently. So getting some insight into what the future holds for Mina and some of what the vision is super exciting. And we do have some questions over here. If you're willing to answer a couple of these. So the first one is we have, what would you say are the pros and cons of using ZK proofs for verifying off-chain data, as opposed to like an Oracle network reaching consensus on the data?
I think the main difference is that it's really nice to have the ZK proof part of it, because then you can have this privacy component. So I can prove something that has an Oracle, but also has privacy involved. So I can say, hey, here's a fact that is signed by my financial institution, but I'm actually only going to reveal the part of that that's necessary to use the application, not the actual underlying data, which is very important for putting things publicly on chain. I would say one advantage still of the Oracle system that I think will probably be temporary, but is the case at the moment, is latency. An Oracle network can come to consensus on something like a price feed much faster than you can produce like a bunch of proofs for it.
Curious to follow up on that. You said you view that as a temporary thing. Why do you say that? Do you think like ZK will progress to the point where it can rival that latency?
They're getting a lot faster, and yes. So I think basically at some point it'll be like the challenge of coming to consensus on like this n-squared Oracle network versus just producing this local zero knowledge proof, and eventually that will get faster. It might take a while, but it's going.
Yeah, no, that's super awesome. Thank you for that. The next question is, in an ideal world, when you submit proofs of data, for example, a credit score, do you imagine the data is still stored in a third-party server like Experian, or is instead owned by the user?
I think it's kind of a temporary state that we are submitting proofs of things that will be on third-party servers, just because that's where the data is already. Eventually, it would be great to say, I've been interacting with this crypto loan protocol for a long time now. I built a reputation up. I'm going to show you my reputation is high without actually revealing the underlying data about those particular loans, for example, that I am working with. So I think eventually this will all be owned by the user fully. It's a kind of temporary thing where it's third-party servers.
Cool. Yeah, I mean, that makes sense to me, kind of dependent on where the ecosystem progresses, I suppose. So then what part, if any, does Kimchi play in improving TPS and scalability?
Definitely helps a lot. So I want to say it's like 2x faster for proving and 4x faster for verifiability. So that just kind of for free gives us much faster block proving time, and it gives us much faster time for clients proving facts. And also the verification speed improvements mean that it's easier to scale TPS as well, because it's you can just verify more proofs in a shorter amount of time. So it definitely helps a lot with it.
Cool. So then 2 more questions on here. So the next one is, if I'm not mistaken, there's work going in the Mina bridge. What do you think are the most impactful ways Mina can interact with the Ethereum ecosystem, or whatever other ecosystem?
Yeah. I mean, I think we're going to see things be very cross-chain. So I think, as an example, we could see a DAO that is deployed on Ethereum leveraging this voting scheme I've talked about for it to be able to get anonymous, like censorship resistant voting without having to, like very efficiently and easily. So this is a world where the Ethereum DAO says, okay, like we want these set of voters to vote on something. Mina creates a proof on its side saying, hey, like here's the result of that proof as a snap. Because Ethereum can fully verify Mina, the Ethereum DAO can then go back and say, okay, I've seen this proof on Mina that says this is how everyone voted on this DAO vote. I can then apply the action of that on the Ethereum side. I think we're going to see like a bunch of composability things like that.
I definitely agree. I think that's a super exciting topic, and I'm very curious and excited to see how that unfolds personally. So then the last question that we have is the thought experiment. I think that's what that meant to say. High numbers of consumers start deploying their own cloud clusters to host their personal graphs and run automated tasks. Would this scenario shift some of your objectives or architecture?
I think actually be very compatible. I think what would be really cool about this world is you would probably still want some kind of state layer. And this is probably actually the world we're kind of imagining, where we're imagining your own device is where your own data is owned and stored, but you still have to interact with some kind of public kind of universal state for coordinating with other people when you're building applications. So in that world, you would take the thing in your private, the little node, which we're imagining right now is your computer, your phone, or whatever, but eventually could also just be something hosted. And you produce a proof of it using zero knowledge proofs, and you submit that back to this kind of shared blockchain. So I think that those worlds are very compatible, and I think that the best actually they're kind of both happen and work together.
Awesome. Well, hey, thank you so much for joining us. That was an amazing presentation. I'm sure everybody here got a lot from that. We'd love for you to hang out. We know you're a busy guy, but thank you so much for giving us your time.
Thank you. No, it was great to be on and chat about stuff.
Sweet. Take care.